Today we will be taking a look at division with the expanded notation strategy. First we have done the area model, and then students have been practicing expanded notation this week at school. So I'm going to take you through that step by step. Again, if you're practicing at home, which is highly recommended throughout the division unit, you practice with a strategy that we have learned in school, either area model or expanded notation. Using the standard algorithm, which is the way most of us usually divide, is not a strategy that we will learn this year, and introducing it sometimes results in some confusions that we're trying to avoid. We're really focused on developing place value concepts and a real understanding of the process of division. So we are going to get started. We have 936 divided by 3. So first, let me just kind of review some of the division vocabulary that your student needs to be familiar with. When we take a look at this problem, the number that we are dividing, 936, is called the dividend. It is being divided by what is known as the divisor, and then the answer we will get will be called a quotient. So all of those words students should be familiar with in 4th grade. They should know if you ask them to find the quotient, that automatically should trigger division, the operation of division. So with expanded notation, we do use what should be familiar, the division bracket, like that. And we go ahead and we place the dividend in our bracket, and we put the divisor to the left of the bracket. So it does start just like the standard algorithm, so it'll be a nice transition when that does get introduced, because this sets up the same way. What we don't do with expanded notation is we don't draw the area model, the boxes. You'll see here that the boxes get replaced with equations going down. What was in the boxes is still present in the problem. And we start here by going to our largest place value, which is 9 in the hundreds place. And what we say to ourselves is, if I have 9 hundreds, if 9 is bigger than 3, do I have enough? Is 9 enough for 3 groups, or groups of 3? Well, 9 is bigger than 3, so I do have enough hundreds to start passing out my 936 cookies in groups of 100. So again, we're trying to find more efficient ways than just splitting up one by one. We don't want to count out one by one up to 936. That's not going to be the most efficient use of our time. We could start passing out in groups of 100 cookies to each of our 3 groups. So if I know that I need to pass out in groups of 100, I'm going to think over here to my divisors 3. Multiples of 3 are really going to help me solve this problem, finding out how many 3s are in 936. So I encourage kids to go ahead and write their multiples of 3 going down the side. Just skip counting up until 21, up until the 10th multiple, which would be 30. Some kids will know their multiplication facts right away and don't necessarily need to see this, but we have found it to be very helpful. Most kids are using it in class, and it's helping them a lot to be able to quickly kind of see what groupings will work. So I know that I'm going to start passing out in hundreds. So that means I'm going to multiply 3 times 100, 3 times 200, and we already know that when we multiply by 100, we can add 2 zeros. The product will have 2 zeros on the end because 100 has 2 zeros. So we're going to go ahead and add our 2 zeros so we can see all the multiples now of hundreds, of 300s actually. And then we ask ourselves, how can I get as close to 936 without going over, so I can pass out as many groups of hundreds as possible? So if I look at my list of multiples, I see that 300, 600, 900 is getting closer. 1,200 is bigger. I don't have 1,200 cookies to hand out. So I'm going to use 900. I can pass out 900 cookies the first round with my hundreds. Well, how many hundreds would I pass out? 100, 200, 300. So I go ahead and I show that I just passed out 300 cookies in 3 groups. And if I do that, I pass out a total of 900 cookies. And I want to subtract now those 900 cookies to show that I've already taken care of them. They've already been distributed. I'm done with them right now. And I only have these 36 cookies left to pass out. So now that I've taken care of all the hundreds, I know that I need to move to my next place value, which would be taking care of all the tens. When I look over here at my list of multiples of 300 with 2 zeros, I know that multiples of 10 only have 1 0. So something we've done in class is just done a quick like that, so we can just kind of focus on the multiples of 30 or skip counting by tens. And then we say to ourselves, which gets me closest to 36? Well, I see 30 right here. 60 would be too big. So how do I make 30 with tens? It's 3 times 10. So I'm going to now give my 3 groups, I can even draw my 3 groups. They each all at first got 300. Now they're all going to get 10 more. To show that, I'm going to stack 10 on top of the 300. And then how many? By giving 10 to 3 groups, I passed out 30. And I have 6 cookies left to pass out. So I've taken care of hundreds, tens, and now I'm into the ones. So if I look over here, I have 6 left. There's a 6 right there. 3 times what is 6? That should be a fast fact. 3 times 2, we show it up here by stacking on top of the tens. And then we subtract 6, and we now have passed out all of our cookies. I can go ahead and give, oh, my circle's not big enough, but we'll pretend. I'm going to have 2 more cookies to each of my 3 groups. And then to find out what my final quotient is, I need to take these 3 partial quotients and add them up. So that would be 312. 936 divided by 3 equals 312. Or I could think of it this way. 3 times 312 equals 936, because multiplication is the inverse operation of division. So as you see here, this looks a lot like the standard algorithm, except that we're not just working with the 3 and then putting our 1 here and our 2 here. We're focused on each place value, one chunk at a time. And then we can add them all up in the end to figure out our final quotient. We have also been working on word problems. So tonight's homework does involve some word problems, and you'll want to be very careful to pay attention to what your dividend should be and what your divisor should be. All right, have a great night.